Howdy, class. My name is Miguel Jimenez, and today we're going to be talking about my project, which is Project 134 for my math class, Statistics. Now, our project is based on 250 male heights, randomly selected. So quickly, let me go over the group norms. First, we communicated through text message. Secondly, we divided the tasks in an organized way, which we considered using our own skills and using those skills that we have to help each other. Third, we met after class in the library. And fourth, if we had a member who did not participate in this project or replied within 24 hours, they were kicked. Now, let's get straight into this. Question one, provide a main title. So the main title for our project, as stated above, was 250 male heights. Now, here is a snippet of those 250 male heights. Now, if we click the link right here, we're actually taking a StatCrunch where we can see right here the data set that we used. So here is the data set that we are working with to get the results that we got for our project. Now, moving back, let's continue. The second question asks the following: is the data set a sample or random population? Provide a sentence explaining. Now, the author does not provide an estimate for the population standard deviation, but what we did conclude and were able to find out through our investigation is that it is a sample and not a population. The third question, moving forward, it states evaluate the 5-number summary. Now, we have to use technology to confirm our results, but we can also do it on paper. It takes a little bit longer, but here is the results that we got using StatCrunch and using the one variable statistics from StatCrunch. Now, as you can see right here, we're doing 250 male heights. So the N represents the number, and our number is 250. Our minimum value, so our minimum value of all the heights, of all the inches, like of all the heights of the 250 men, the lowest value was 63.2 inches in height. That's a short king. Our quarter one, are also known as our Q1, is 67.7. Our median is 69.7. Our Q3, also known as our third quarter, is 71.7. And now our maximum value, the highest height among all these 250 men, was 77.3 inches. Now that's a talking. Here's another representation or a 5-number summary, as you can see right here, just in a more orderly fashion. Now, the fourth question, moving on. The fourth question says evaluate the mean, the variance, and the standard deviation. Now, it's asking us to properly type and formulate all our formulas and variables. And that's what we did right here. So we have to also follow the same format as the previous question. So we have to use a repeat of our mean, our sample variance, and our sample standard deviation, just so you people watching at home understand what the numbers we are working with. Now, here is, for example, the mean, the variance, and the standard deviation, once again, alongside the corresponding formulas in which they go with. So we can take a look right here at the mean. X bar equals the sum of x divided by n. That's how we got 69.7832. The same thing goes with the variance and the standard deviation. This is the second part of our project. Now, this link right here is essentially the same link that brings you to our data set. This is just easier for you to see, so you can take a quick glance at our numbers to make sure they're corresponding, to make sure you're matching with the numbers that we got. Now, question 5. Let's take a look at question 5. Question 5 is asking to evaluate the following and to show all steps and formulas provided the same format as questions 3 and questions 4. Now, the first part, 5A, it's stating provide the IQR. Now, the IQR is Q3 minus Q1. So third quarter minus the first quarter. Now, our third quarter was 67.7. Our quarter one was 71.4, which gives us a total of IQR equals 4 inches. Now, the second part of this question 5, evaluate the z-score for the minimum and the maximum values. Now, as we look back, we can see that our minimum value is 67.7 and our maximum value is 71.7. Now, we're going to have to use the mean in order to get this z-score, and using also the standard deviation to get the z-score. Now, here's actually the formula to get the z-score if you want to input this manually. We're going to use x minus x bar divided by the standard deviation. Now, for our x, it's going to be represented as 67.7, and our x bar, which is representative of our mean, we're going to put 69.7832 divided by the standard deviation. Now, once we concoct these formulas, we can outline this clearly in a sentence, and it goes along the lines of the z-score for the minimum and the maximum values is negative 2.80965,912 and 2.604442302 for the maximum. The third part of this question 5, it's stating evaluate the usual intervals using the mean and standard deviation. Make sure to provide all proper units, sentences, and formulas. Now we're going to have a repeat of putting our mean, our standard deviation, and here's the formula highlighted right here that we're going to be using for this. Now our formula is going to be mean plus or minus 2 times our standard deviation. Now the units we're going to use is our mean plus or minus 2 times our standard deviation. So we're just going to plug in the numbers, 69.7832, which is our mean, plus or minus 2 times 2.8861457. Now, once we formulate these results, we get a usual interval using the mean and standard deviation, which is 64.01090856 and 75.55549,144 inches. Now, we're going to evaluate the usual intervals using the lower and upper fences, providing the proper units, sentences, and formulas. Now, here's our formula that we're going to use. We're going to be using our Q1 and our Q3 and our IQR. So for the lower fence, it's going to be Q1 minus 1.5 times IQR. Now, when we plug that number in, we get 67.7 minus 1.5 times 4, which is the IQR, and it gives us 61.7. Now, we repeat the same process with the upper fence, except with the fact that we replace Q1 with Q3. So it's going to be 71.7 plus 1.5 times 4, which gives us a usual interval using the lower and upper fence is 61.7, 77.7 inches. Question 6. Now, question 6, all we're doing is providing the graphs that go along with our data set and the numbers that we got with these data sets. Now, the first one, it's asking for a stem plot. Now, if you took a look right here, you can see that this is not your usual stem and leaf plot that you're likely used to seeing in your statistics textbooks and online. This is a different type of stem plot. This one doesn't just place down the numbers left to right, how you typically see a stem and leaf plot. This is one provided by StatCrunch using their stem and leaf plot calculator. Now, because our data set has a lot of decimals, it is difficult to do a traditional stem and leaf plot. So this electronic one, this one we got from StatCrunch, is a better representation as well. As you can see, the dots go left and right according to this red bar right here. That's essentially the same pattern that we would see in a traditional stem and leaf plot, but now it's just placed in a graph. The second graph, we have a bar graph using 5 classes. Now we can take a look at the 5 classes right here. Here they are, up to 250 men's heights in inches. A whisker plot, a box and whisker plot. Now, if we take a look at our box and whisker plot that we can see right here for our 250 men's heights, we can sort of see that the right tail of this whisker plot is actually slightly bigger than the left tail, meaning this box and whisker plot indicates to us that our data set is skewed to the right. Now, here's just a dot plot for the numbers. And that is my part of the recording, and my partner will do part 2 starting from 7. Thank you.